start recording this and sharing the screen. Okay, so here we go. So what's going to happen today is we're going to start talking a little bit about exponentials in more of an application setting. Okay, I mentioned yesterday, like if you threw a mushroom out in the forest, what's going to happen to that mushroom? It's going to decay over time, is it not? Or maybe if you go ahead and fed it and you planted it, what would it do? It's going to grow over time. If you took like a roast out of the oven and you put it on your kitchen countertop, what's it going to do? It's going to start cooling down. All of those things are applications of exponential growth or decay as they kind of happen. The more common one that you guys are going to think of is like putting money in the bank. What happens to money when you put it in the bank in a savings account or in a money market account? What should happen? It's going to grow, and they always give you a percentage of growth, right? They say, hey, we're going to give you 4.25% interest, or I'm going to borrow money and I'm going to pay you 2.5% interest, whatever it is. All of those things are examples of exponential functions. But what we're going to do is we're going to deal with application today. Unfortunately, that kind of means we're talking word problems. But how they play out is the amount that you have is usually going to be considered a function of the amount of time that it's going to be out there. And we start with the initial condition, a sub 0. So in physics, if you ever see a little subscript 0, that's a way of saying initial condition, where we started our world, which we saw in one of those problems earlier today. In fact, the one Montserrat said, we highlighted 0, right? That was that initial condition. Now, in the lecture that we gave the other day, that I talked to you guys about yesterday, 100% is our break-even spot, isn't it? What happens if it's 100%? So you're not growing, you're not shrinking, you're just staying pat. So what we're going to do is we're going to write 1 plus your rate of growth. Now that 1 literally represents 100%. So if something is growing at 6%, what's going to be right in here? It's going to be 1.06, because if you're growing by 6%, 1.06. What if I said you're decreasing or decaying at a rate of 3%? It'd be 1 and a minus 0.03, or 97%, so 0.97. So you see, we're going to get some number above 1. Hey, that's exactly what we said yesterday if you're growing. And what's going to happen if you're decaying? It's underneath 1, but always above 0. That's a little bit strange. You got to remember that. It has to be above 0, because you're never going to lose more than what you have. And notice it's supposed to depend on time, right? And that's going to be raised to the t power. So effectively, what's going to happen is if we have, let's say in each one of these cases, I'm going to give us an initial condition. And a percentage and a frequency out here. I'm going to try to make this kind of formulaic so we don't have to write every single one out. See, in a normal textbook, we'd write a whole paragraph describing this whole series of events. So let's say you had 17 of something. It doesn't matter what that something is. And we're increasing at 3.2% per year. Now, there's a reason I'm going to go through some of this stuff in a second. So if I were going to come up and make this equation, then A of t, and the first part of what you're going to do today is literally, can you make equations out of these things? Well, what was my initial condition according to this? 17. It is increasing at 3.2%. So that would be 1 plus 0.032, because remember, how do you turn a percentage? Boy, that's been a long time, I bet. How do you turn a percentage into a decimal? You move it over 2 places, don't you? You've done that. I mean, but it's probably been years, hasn't it? That's 1.032 to the t power. That's literally the entire story. We could have written an entire paragraph. That's a very uninspiring result, isn't it? Pretty simple little idea. Now, I'm going to leave a little bit of a gap here because I want to do something else in that little bit of a hole there. So what if we changed it to 38,500. Now that's a little bit of a shift, but you know, it could be a case where, you know, instead of talking about, you know, I don't know, something simple, you're talking about like you bought a vintage car. Now I didn't say a normal car, because what do cars normally do? They decay, they go down in value. You drive that thing, you lost a lot of money, but in a vintage car, does it sometimes go up in value? You know, you get yourself like a really, really nice thing that somebody has restored, and we say increasing at 2.75% biannually. Now that just changed the whole story a little bit, because I'm not saying it's happening once a year, I'm happening twice a year. Well, I need to go ahead and add a little bit to my story, because sometimes when it doesn't just happen once, we change the formula ever so slightly. You go like this, it's 1 plus r over n to the nt power. Now again, I could go through a whole bunch of stuff as to why all that's the case, but guess what? Do you guys know what n is going to stand for? N is going to be the number of times a year it happens. So if it's biannually, that means how many times am I going to get that benefit? Twice a year, no big deal. So my A of t in this story is going to be 38,500, because that's my what? My initial condition. I'm going to go 1 plus 0.0275 divided by 2 raised to the 2t power. Now, why is that 2 there and that 2 there? Because I'm saying I'm going to get it twice a year. Now, some people are like, oh, so does that mean you're getting like 5.5% a year? No. In fact, the first time they give me interest, they're not going to give me 2.75%. They're going to give me 1.375%. They're going to give me half of the year's interest, because how much time has elapsed? Half a year. And then at the end of the year, they're going to give me the rest. Will I be better off or worse off because they gave it to me twice a year? I get it more often. So wait, that's going to be better though, because then I'm going to get interest on that interest. Does that make sense? So if you get interest on the interest, it's going to grow a little bit faster. By the way, that was the thing that we talked about yesterday, that 1 plus 1 over n to the n power. There's going to be a limit in this thing. What was 1 plus, I know there's an r in there, I get that. But 1 plus 1 over n to the n, what did we get yesterday when we started screwing with that with our calculator? Yeah, it was 2.71, and it was that special number we called E. And so people are like, oh, if I go faster, it gets more. And then I go faster and it gets more. Well, there's a limit on how fast you can go. It doesn't matter how fast. E is this overarching limit. So anyway, this is the story here. Again, I'm going to leave a little bit of a gap because I'm trying to save us some time here. So how about now if we had 0.843 decreasing at 0.43%, and this one is going to be compounded monthly. Now, as soon as I said monthly, what did I just do to the amount of time it takes to happen? What did I turn n into? It's 12. It's no big deal. So again, I'm purposely leaving some gaps in these holes. I hope I left enough room. So could somebody tell me how to start this little jaunt? What do we start every single problem with? Our initial condition, which in this case was 0.843. Not everything is huge. Sometimes you have very, very small values. There are things like, you know, gold and titanium that are very, very valuable. You maybe only have a little teeny bit of it. Did you guys know that your cell phone has gold in it? You know why it has gold in it? Yeah, it's a very, very good conductor. It takes electricity and allows it to flow very, very easily. Now, how much gold do you think it has? Very, very little, but like one of my favorite shows to watch, this is kind of dumb, but I like it. Have you ever seen Gold Rush? I love the show Gold Rush just because these people are just in the middle of nowhere and things break and they just have to make it work somehow. And I'm just intrigued by people being able to make something out of nothing. But in the big scheme, I mean, they have all this machinery doing all this stuff and they produce all this gold and all of it goes into cell phones. So when you think of gold, you're thinking, oh, they're going to make earrings and jewelry and wedding bands. No, all of it is little teeny flakes of gold that are going to be used in electronic parts, televisions, cell phones, etc. That's what it all goes to now. I thought that was kind of an interesting little factoid. But what's going to happen in this story? Now, where's the 1 from again? 100%. That's where we start our story. But then we're going to lose. Why am I losing? Because it says decreasing. Now this is obnoxious. 0.0043. Oh, that's mean, isn't it? Because I didn't say 4.3%. I said 0.43%, which I have to move it over 2 places to turn it into a decimal. And that gets divided by 12. Well, and therefore to the 12t power. You guys okay with that? Now, could I turn this into a simpler decimal? In fact, usually we will. In your homework, I would like you to go ahead and find out what this obnoxious little thing is and just write it down, usually to about 3 decimal places. Okay, now it's time to, well, I got one more in my notes right here. How about 275? By the way, is the initial condition even matter? It doesn't make it harder or easier or anything like that. It's just kind of dumb. This one is going to increase. I guess I got increase on my brain. Yeah, never mind. We're going to do decrease. I've done too many increases. So this guy is going to decrease. This is not so good. It's going to decrease at a 15.2%. That's terrible. Per decade. Oh, I just changed the world a lot there. So what am I saying is when I did biannually, it was twice a year. Here it was 12 times a year. And then this is like, this isn't, so it's getting faster and faster and faster. What happened all of a sudden? I just slowed the train down, didn't I? It's like, I just ground it to a halt. Well, that's going to be A of t is 275.4. I missed the 7. 1, it says decreasing, minus 0.152 divided by, ooh, if n is the number of compoundings per year, see, this is actually kind of a deceptive little sucker. Sorry about that. It's supposed to be 1/10 t. Because I'm saying at the end of that time, that would have happened. So 1 time every 10 years this occurs is kind of how I'm trying to imply that. I'm not going to actually put that there. Why is it 1/10? Because instead of going faster, what happened to it? It went phenomenally slower. That kind of bothers people. Now, the reason I left these little bit of a gap in each of these places is because there's another thing that will be said occasionally. And so to kind of try to highlight that, I'm going to actually change colors, is we will use this word continuously. And by the way, anything that is affected by nature happens continuously. We talked about how a mushroom would grow continuously over time if it's got the nice warm, moist environment, but it looks very much like what we have. You're going to start with A0, but what happened is n went to infinity. That 1 plus 1 over n to the n power as n went to infinity goes to e. So this is weird, but it goes e to the r t. Now, I want you to notice what is not in this story, everybody. Really important, because last year and the year before, oh my gosh, I had to fry 1 million people on their test on this thing. There is no 1 in the story, is there? There is no 1. So in purple, in every single one of these, I just want you to follow everything that is done in purple. I'm changing the story to continuously. Okay, so if I said it was a continuous rate of decay, or a continuous rate of growth, we're going to use this fancy formula. So as soon as they say continuously, that's a trigger to say that A of t is still going to be 17, e raised to the 0.032 t. Where did the 1 go? It was actually inside of e. Because what was e? E was 1 plus 1 over n to the n power from yesterday. The e has the 1 in it. Don't put it back in. Because if you put a 1.032 here, like we had here, you're saying it's not growing at 3.2%. You're saying it's growing at 103.2%. Okay, going to the next one. Here's my next continuous. This one is 38.5. So A of t, the amount that you have at some time t, would be e raised to the 0.0275 over 2 t. Do you guys see what's happening? Is that hard? Just throw in those two numbers. You just need to know A0 and you need to know R. So what do you guys think this one's going to be? Let's go to the next one. Initial condition, 0.843 e to the, see what you got. This one is decreasing. What is R then? Negative. Why is it negative? Because it's going down. Oh, yeah. Well, excuse me. That was a poor choice. Please erase that. I wasn't thinking. I haven't done continuous growth and decay in a little bit. It's continuous, so we don't even need to recognize these two values, so don't worry about that. Don't do that. It's just the RT. There is no compounding value. That was just a stupid thing on my part. So when you deal with continuous growth and decay, that's kind of what happens. You just go ahead and give your initial condition and all this other stuff. So my last little piece, how much time? I got enough time. Is I made up a story here, and here's my story. If the half-life, have you guys ever heard of half-life? Who talks about half-life? Chemistry always talks about half-life. So here's what I got. The half-life of nolonium is 47.2 days. By the way, have pretty much every kind of radioactive material been studied pretty significantly? Do you guys know that? I made this up, by the way. There is no nolonium. I was thinking of science teacher. But there is californium. What do they call Berkeley? Do you guys know what they call UC Berkeley? It's called Cal. Guess where californium was discovered? At Berkeley. Oh, by the way, there's berkelium too. They kind of did that one too. But they already used berkelium, so they went with californium. Anyway, so they study all these things, and it's literally how much of that stuff, and it's weird because you have like this thing that has a radioactive stuff, like it's sending out these alpha particles and stuff. It's not like it actually shrinks. It's just the amount of it that actually is radioactive goes, and it decays down to something, and it's still like, say it was 12 grams, it'll still be 12 grams, but it's just, part of it will still be californium, and another part of it will be whatever the decayed state of californium is, which again, that's chemistry that's just gonna be way beyond me. But anyway, so let's suppose that we have some new thing that we found. Mr. Null was messing around back in his trees, has much eucalyptus trees. Anyway, and he finds this nolonium stuff, knows that it has this half-life. How long will it take to decay 37 grams to 12 grams. Okay, so here's what I've got. I've got this interesting little story, and it's half-life. So how much of it has disappeared? Half. Now, by the way, in the real world, this is considered continuous or incremental. What do you guys think? Does something like an alpha particle, does it decay continuously or does it decay incrementally? It's continuous. It should be a continuous growth and decay model. I will tell you that right off the bat. But in science, they pretend that it's not because they talk about half-lives. So here's what we're going to do. What percentage of it went away? If it's half-life, how much did you lose? 50%. That's why. So it's going to be this equation right here, but you're going to be using R is 0.5. So we're going to end up with this kind of story right here. The amount at some time t is going to be 37 grams, because that's what we had, raised to the 1/2, and it's going to be t over I'll do that right here. Actually, excuse me, it's going to be x over t. See, because I would like to know how much time it actually took to do this. And so how long will it take to do that? But see, I told you that the half-life was 47.2 days, so I guess I could put that in right there. Now, later on in our course, I'm going to show you how to do this the real way, but for right now, I'm going to show you the absolutely stupid way to do this. I want to know, when is that thing going to be equal to 12? This is my big question. This is how they actually generally will tell you to do this in a science course, or they sometimes will give you one other little piece of data that's just really bizarre called an anti-log, which we don't really, anyway, that's a different other story. But here's what I want you guys to do. Take out your little Desmos or your graphing calculator, I don't care which. We're going to go ahead and pop this thing across. This will work with either one of those things. I'm personally, I think I will use the graphing calculator. A lot of you seem to be grabbing graphing calculators, so let's go ahead and go that direction. Let me go ahead and make this thing go away here for a moment. So I'm going to go in here to y equals, and I'm going to type in my equation. Now, why was it 0.5? Why was it 1/2? Because we're talking half-life, which meant half of it went away. And it went away every 47.2, I think we said, days. Okay, that's important to know what increment of time we're dealing with. And this is, like I said, the absolutely stupid way to do this. I'm just going to hit 12. I want to know when is that guy equal to 12? Now, in terms of my window, so what I'm going to do is I'm going to graph this. By the way, this is exponential decay, right? It's coming down. How much should I start with? How much did we start with, everybody? 37. So when I go to my window, then I know that I have to start with at least 37. So is 40 okay? I want to know, when is it going to hit, I think we said the number 12. So if I said y, or the answers went from -10 to 40, would the number 12 be in there okay? Now, let's think about this for a second. Guys, what is one half-life? After 47 days, how much is going to be left of this 37 grams? Exactly half of it. So in 47 days, 37 is going to turn into about 18.5. Have I given it enough time? No, it's going to take a couple of half-lives, isn't it? It's going to take a couple of those. So instead of going from, say, there, how much time should I give it? How much time do you think it's going to take to get all the way down? If every 47 days I lose a half, which means 30, let's go with 40 because it would have been easier. What would 40 turn into in a half-life? 20. And then 20 would turn into 10. And then 10 would turn into 5. I'm going to give it maybe 3 half-lives because it's got to go for a while. So I'm going to give it about maybe 130 days. Now, there's nothing magical about that. I just want to make sure I give it enough room to do its thing. And if we graph it, here comes nolonium. It's decaying down. Here comes my magic answer. I said I wanted it to be the number 12. What do I need to find? Oh, yeah. Let's calculate which one. That'd be 5. Ding, ding, ding. And so it looks to me like about 76.7 days. Is that okay? So it appears that in about 76.7 days, we will have that. So what actually happens, have you guys heard of sometimes like the big nuclear accidents that happen, like Chernobyl? You guys heard of that one? That was a big deal. So they knew when they had that meltdown and some of that radioactive material got out, do you think they knew how long, like what level was okay to survive? And so they would plan it out and they'd say, okay, so this area around Chernobyl will be habitable again. It'll be okay. It'll get better. Just takes 3,000 or 4,000 years, and then people can move back in and we'll be all right. They did this. I mean, that's what they're doing, is they have a crazy equation. They know what level is actually safe for people to be around. Do you follow that? Just graph it, find out where they cross. Now, there's a better way that we'll learn later, but that'll work. So what you're going to do today is you're going to come into here, and you're going to go through those. But I didn't do 2 for 1. Notice in number 12, there's a word that you want to watch for. Do you notice number 12 has the word continuous? So you're not going to use the 1 plus 1 over, 1 plus r over n to the nt power. You're going to use the e one, right? Yep. Is there any of these others that you will use that? 14 is definitely going to be there, but it says decreasing. So what kind of r value are you going to have? Okay, so we have about, let's see, I think we get out at 9:06, so we have 15 minutes. I think you guys should be able to blow through a lot of these pretty quickly. You just let me know if you have questions, and I'll come back to you. That was about as quick as I could make it. And hopefully that was pretty good. Let's go ahead and stop the share. And let's go ahead and